I would take a peek at that. So, okay, this is what we're going to do then. So we're going to perform a significance test, which we've done already in chapter 9. I think it was for proportions. It's chapter 9. And so now what we're going to do is do it for means. So chapter 10 was all about confidence intervals for means, so making a range of numbers. And now we're going to test some data and see how significant it is. So we're going to set up a hypothesis. We're going to get like kind of like a z-score, but we're going to call it something else. So we're going to do that together today, but then we're also going to look at the connection between confidence intervals and significance tests. That's my bird clock. I'm just going to let that run its course. Sunlight triggered it today. Okay, welcome to my home. There's the birds in the Mediterranean, I think, actually. No, it's some rare bird. I better go find it. Okay, anyway, but we're going to look through the connection between intervals and tests, because a connection does exist. We just haven't explored that yet, but that's what we're going to do today. So I'm going to share my screen a little differently today, because I'm going to need to use the calculator and demonstrate some things for you. So I'm going to share my entire screen. Okay, can somebody confirm in the chat that you can see a calculator? Just give me like a yes or no. Great. Okay, perfect. Now you probably see yourselves. Okay. All right, calculator, boom. All right, so we've got our data here. So what we want to do is investigate what is normal body temperature. So we have our class data. I'm included in this set. First of all, we have a sample, and we want to tell ourselves, the sample size. So 1, 2, 3, 4, 5, 6. We have 6 for our sample size. So we're going to say some prayers and pretend that's normal. But then we need to get the average and the standard deviation. So this is some questions on the AP exam or in general. I mean, if you're a general statistician collecting data, you're going to have to, actually get your averages and standard deviations and calculate those. So if you have your Chromebook calculator, or some kind of graphing calculator, you're going to want that open. I'm going to show you how to get your average and standard deviation. Again, this is a good little trick for the AP exam, so you don't have to calculate things by hand, because we don't want to do that. So you're going to push the stat button and then the edit button. And I put the data in as it was coming in, but you just type this on the number pad in any of the lists. List 1 was open for me, so I went ahead and typed in the numbers. And then you go back to stat and calc, and we're going to do 1 bar stats. I'm going to hit enter. And then I'm going to hit second, and then L1 is right here above the 1 key. So I'm going to type that in. Your screens on your Chromebook calculators might be a little fancier than this one, because they're a little more up to date, but you still have to input the list. It might default to list 1 though. Sometimes they do that. And then you hit enter and you'll see X bar. So right there is our average. So for our small sample here, our average temp is 97 point, we're going to round it, 97.8. And then our standard deviation is the SX. So our temperature deviates by about, we're going to say half a degree. So I'm going to round that as well. So 0.5. So on average, we can expect our class temp to be 97.8, but then we're going to deviate by about half a degree. So we've got our data there. So that's that. But now what we want to do is test out how significant is this. So what is normal body temperature? Doctors say it's about 98.6. Technically, you don't have a fever until it's like 100.2, I think now. For me, I always feel really crappy when my body temperature is like 99 degrees, but I always ride a solid 97.1. That's been my temperature for the last year. Take my temperature a lot now. But normal is considered 98.6. So what we're going to find out today is just in general if this is true. So right now, our sample average is less than 98.6. So we just want to see in general if this is true. So what we're going to look at is a not equal to kind of hypothesis. So not greater than, less than this time. We're actually going to look at a two-sided test and see if it's, what's going on there. So for our statement, we're going to do kind of the 4 steps here together. We've got 4 things that we generally include in this step. And the first of which is defining what in the world we're kind of measuring. So I'm testing the significance of temperature. So it's the true mean body temperature. Is what I'm looking at. And this symbol is important because that's for the population. X bar is your statistic. So I'm going to put that over here. So our sample statistic, 97.8, that's just for us. That's just for our little sample. And then our hypotheses, hopefully this looks a little familiar. We have our hoes and haws. We have our null, which is this one, and our alternative to that. So we're going to assume that doctors know what they're talking about for the sake of this example, and assume that normal body temperature is 98.6. For us, we're just concerned if that number is true or not. So we're going to say we don't care if it's significant, in the less than direction or the greater than direction. We're going to do a not equal to scenario. So we just think normal body temp is probably not equal to 98.6. Any questions? This is going to get weird because you're going to see yourselves. Any questions about the state part so far? I have to look at all of you now. You have to look at yourselves because I have to see the chat because I'm sharing my whole screen. Any questions about the statement? State part, hypothesis. It's been a second since we set these up. You can drop it in the chat, sorry, if you have a question. Or just shout at me, either way. Okay. The only other thing we need is our significance level. So that's our cutoff point. So that's like our probability, how low we're going to let it get before we think, ooh, that's kind of sus. That's a little weird. Our default is always going to be the 5%, or alpha is 0.05. We can adjust that to different numbers. We're going to explore that kind of at the end. But for the most part, we default anything that has a less than a 5% chance of happening, we deem as weird in the stats world. So now the only thing it did say here in our first part, assume your conditions have been met. Yay! I don't have to check the random and the central limit theorem and look at my data and see if it's approximately symmetrical. I don't have to do any of that because I already said those were met. So we're going to skip that part. They're generally the same as what we've been doing in the confidence interval part. So if you need to review the conditions again, you can kind of look back at chapter 10, or you could look back at the lesson yesterday if you haven't had an opportunity to do so yet, because I go over it in that as well. But we do have a different name. This is going to be a one sample t-test. We're not going to make an interval this time. We're going to see how unusual our value is. So we're testing to see if something is significant or not. And that's for our population average. So we're doing a one sample t-test for mu. So what I'm going to do here is kind of draw out our picture. So if I were to do sample after sample after sample. If I was smart, I would have kept all the data from previous classes. But basically, what I want to do here is if I were to do this over and over and over, if I took little samples of 6 and I said, okay, you take your temperature, I'm going to get the average of those 6 and do it over and over, I would make a dot plot. And we would hope this dot plot would be approximately normal. But it's going to center around what I think is true or around my null hypothesized value. So we're going to assume all right, this is what doctors say, 98.6, let's test it out. So in general, we would expect that to be kind of our common value that would happen. And then we're testing our value out to see, where that falls. So this gets a little bit wonky because our value was 97.8. I'm going to shade it in on this end. But I'm looking at a not equal to scenario. So here's kind of what that means. I'm also looking at the fact that what's the chance that it also is greater than my 98.6. It could be a little higher, you know, maybe people are just warmer. The Earth is warming, people are warming, I don't know. So here's what we need to do. We want to look at basically how far apart our value was from like where we think the middle should be. So I'm going to do, because I can't do mental math in front of people, gives me anxiety. So now we're plugging in the calculator. There was somebody like 2 years ago on the or on the SAT. I walked as proctoring and I walked around and they plugged in like 2 + 0 on their calculator. And I was like, I could feel that. Like that's, you're just making sure that still works. Okay, so these have a difference of 0.8, like in this direction. And when you do a 2 test, so a situation where you're not just concerned about less than or greater than, you're also going to explore the option like, okay, what if it was 0.8, but up from where we think the middle is? So again, I don't like doing mental math in front of people, so we're just going to plug that in to make sure. Yep. Okay, so then the other value I'm considering is 99.4. So when you do a not equal to, you're looking at both sides of that, and you just have to figure out how far away one of the sides was, because it's a, you know, bell curve, so it is symmetric. So I'm looking at basically what's the chance I land here, or what's the chance I get a sample and land there. So what are those odds, and is that significant or not? So first of all, this is a little different with a two-sided test. I don't know, you're all going to see yourselves again. What questions do you have about how I put in those numbers for a two-sided test of a not equal to hypothesis scenario? Not equal to. What questions do we have? I have to toggle a little weird today. Screen share weird so you can see the calculator, but you can drop them in the chat. Take a sip of coffee. Okay, so let's go ahead and do the work then. Our formula, what we want to do is we want to see what these areas are on our curve. So it's kind of like we took our data value and now we want to, just like a z-score calculation, it's like, all right, here's my data and I want to see what the area is, or the probability is that I fall below this point or above the other point. So what we're going to do is find the test statistic, which before is basically, before we called it just a z-score, but this time it's going to be like a t-score, because when we do averages, the t distribution is pretty close to the normal curve in terms of like the areas and stuff, but it does a little better job of making predictions for a situation where you're measuring an average. So we use a different table we can, or I'm going to show you the calculator trick today for how to look up what is happening. So for our formula, we always take, for our test statistics, I'm going to say test stat, and this is given on the AP exam formula sheet. You're going to take your statistic, your value, your data point. You're going to minus the parameter, which is your hypothesized value, and then divide by the standard deviation. So in terms of symbols, our t value that we want to find, so we want to basically convert our data values into a t value so I can look it up on the chart or plug it into the calculator. I'm going to take my data value, which is my x bar, minus what I think the true value is, or the true mean, divided by the standard deviation, which is this formula here when we're looking at averages. So then I just have to kind of plug in my numbers. So I've got 97.8 minus 98.6. And I got to remind myself what the standard, half a degree. Yeah, half a degree. So I've got 0.5 divided by my square root of my sample size. We had 6 people. So we're gonna go ahead and do that. And you, hopefully, if you're following along, that would be good. Just because there is a lot of calculator stuff. So I'm gonna just plug this in like normal and get some numbers. So I'm gonna get kind of both halves of my fraction here. So then 0.5 divided by the square root of 6. math I don't want to do. And you can round things, just make sure you round them correctly. So I'm going to get a final number here. So I got a t-score of -4. So that's for this value. You could also go ahead and find, you know, the t-score for this value if you wanted to, but it is a symmetrical curve, so you don't, it's going to be the same, just the positive side. So the t-score for this value would end up being 4 because it's symmetric. So let's just take a quick pause. We don't need this one though. Let's take a quick pause. Because we just did. There's a lot of things happening on this slide right now with the calculations. What questions do we have? You're all going to see yourselves again. What questions do we have? Drop them in the chat, or you can unmute yourself. Spice it up today. Okay, so let's real quick, we're going to do kind of two things. So some people are comfortable finding, because we need our p-value. So our p-value is going to be the area of the shaded part, and we have it twice, so we'll just have to remember to double it once we find it. But we have a couple ways we can do that. There's the chart, which you're given on the AP exam. You do get the chart. You don't have to memorize the charts. So what we're going to do, I'll just quickly kind of look at that. You do have to have your degrees of freedom. So for anything with the t-table, t stuff, degrees of freedom is n-1. So for us, that's going to be 6 minus 1, which is 5. So I'm going to be in this row. And then I just have to go along the row until I find something that is close enough to my test statistic. And they just list the positive values in the table. So I'm basically looking for the number 4. And that's going to be this number here is going to get me. That's close enough. So the table is a rough estimate of that. So then I go up here, and that's my p-value. So that's the area that goes with this, roughly this test statistic. And then I would have to double this one because I do have 2 sides that I'm considering to my curve. So I would have to double that p-value if I wanted to use the table. And that's how I would do that. So that's not right. So for my p-value, sorry, mental math, I don't want to do it. All right, my p-value for the table. So I'm going to put my table value in here. My p-value for the table is going to be 0.01. But I can also do this on the calculator. So before I do the calculator, because the table on this one is weird, and you don't have to use it. You can use the calculator trick I'm about to do. That's fine too. What questions do we have? Anything about the table? Drop them in the chat or on mute. It's fine. Yeah, and yep, you just multiply by 2 on this one, Tessa, because we're doing a 2-sided test. Now, if I was only considering, because I decided to just investigate, like, is body temperature just different than what doctors say it is? But if I said, oh, I think body temperature on average is less than what doctors think, then I would just I was gonna cover it up with my hand. I can't do that. Then I would just look at like the one side. If it was like I did this the less than or the greater than, then I wouldn't have to double it. But since I'm thinking of both sides, then I'm doubling it. So just in this not equal to scenario, yep, we would double that number. Any other questions? The table is funky on this one. I typically use the calculator myself, but some people like the table, so we can go over it. Anything else? Okay. If you are typing, feel free to keep dropping questions. I'll toggle back and forth. So let's take a peek of this on the calculator. This is a good trick if you just watch me do the table thing and you're like, yep, don't want to do that. So this is how you do the calculator. You're going to go to second and bars. Oh, okay, yeah, I always have to think every year. All right, and then you're gonna go down. For me, it's option 6. But I'm gonna write the steps here. So second, bars, and then TCDF. This is where you can find the area. Notice there's also normal CDF. So, for Z-score stuff, we could have not used the table this whole time, but y'all like the table, so we stuck with that. But I'm going to do TCDF. And basically what I have to do, and this is a little weird, so some people don't like this and they stick with the table. So if you want to go back to the table after this explanation, feel free to do so. So what I'm looking at, I'm going to draw it out. I'm looking at like this part of my curve, like, right? So I have 97.8 and I'm looking at the side less than that. So I have to plug in the lower value, comma, the upper value, or it might say upper bound on your calculator, comma, I hope the degrees of freedom. I hope I'm right on that. It's been like a year since I've done this. We're gonna try it. Okay, so the lower value is basically just imagining like this curve just keeps going. So I just have to put in a super low number. So I just always go like negative 99999, whatever you want to do. Comma 97.8. And so it's basically like my lower area of this shaded part up to this part, and then I put my degrees of freedom. So for me, that's going to be 5. And I separate that all by a comma. I think that's all correct. We're going to cross our fingers and push enter. Woo. So then this is strange. Hold on. Oh, no. Sorry. Second bars. Sorry. You gotta put in your T number. Sorry, I think. Right? Ooh. Second guessing. Hold on. Sorry. It's early on a Friday. Let me double check before I. Why is that number strange? Okay, hold on. Let me think. That number is weird. Why is that number weird? Hold on. I'm thinking. TCDF. Yep. Lower, upper. Now you're watching me all panic doing calculator things. Welcome to my life. Okay, hold on. Why does that number not match? Oh. Lower, upper. Hold on. We're gonna Google something. Sorry, I'm pausing. We're gonna double check. TC. Okay, steps. Hold on. Oh, won't give me a video. Sorry, people. This was. I don't know. I teach this once a year, and then I'm like, then I gotta go back and remember how to do it. Yeah, I feel like it. Why is that strange though? It looks weird. Dude, lower and upper. Yeah. I'm gonna come back to that. I don't know. Hold on. Okay. Sorry, so watch me freak out. Okay, so lower and upper. Sorry, I'm gonna check one more thing. Sorry. Well, happy Friday, friends. I'm gonna check my key one more time just to make sure. I don't wanna mess up the calculator thing. I don't know why that number looks strange. I feel like I'm having flashbacks to like last year where I did the same exact thing. Like made a mental note, like I need to. Okay, here we are. let's just double check. Make sure I'm doing this right. Oops, not that one. This one. Yeah, lower upper degrees of freedom. Weird. Okay. Double check one more thing. Sorry. Yeah, lower upper. Lower T. Okay, well, anyway, I'm gonna have to look into that. But basically, sorry. Okay, that was a tangent. Did anyone drop questions? It's your dad's birthday today. That's great, Tessa. You tell him to have a great birthday. Okay. All right. So, sorry. On the calculator, we have TCDF. I don't remember why this is giving an odd number, but basically, if we take what the calculator gives us and do 1 minus what the calculator gives us, we're going to arrive basically at this number as well, essentially. So we're going to get a very, very low number for that. So that's one option that probably nobody wants to take now, because that was weird. But there is a third option. So let me show you that one. See if I can't mess that up. To get the p-value. So if you click on test and then go to t-test, stat, and then go to test and hit t-test, you can have the calculator do the test for you. So I have two options right now for how I could do it, because I did have a list for my data, which is already in there. So I could set this up to do it that way. The other option is to hit the stats button here, and it is going to default my values from my list in there for me again, but I could type them in. My hypothesized value is the 98.6 normal body temperature, and then sample size of 6. I'm going to do a not equal to situation, and I can calculate. And this will also give me a p-value. So that's another option instead of using the table or the calculator. So you've got 3 different options, really. You're probably all thinking, woman, why didn't you give us this one first time? But I like to give people choices. So we could also write this down from the calculator, the p-value, which is 0.008. And you just have to say on your AP test which one you did. You can say from the table or from the calculator, and either one is fine. So this is our p-value right now, which is pretty tiny. Now the calculator will double this value automatically. So the calculator will do like the ×2 part, so you don't have to double this one. So just be aware of that. On the table, you will have to double it if it's both sides, but not from the calculator. That's a calculator, so it does that part. So let's see if there's any questions. I probably scared everybody away with the calculator nonsense. Drop them in the chat. What questions do you have about this before we just look at our conclusion real quick? And then more calculator stuff. We'll see if I can't mess that up. Questions, comments, things for the good of the cause. Beautiful. Okay, let's go ahead and wrap this up. So we had a p-value. I'm going to use the one from the calculator. That is 0.008. I'm going to round it. So that's a pretty small probability. So that just says like, all right, I had a 0.008 chance of getting a sample with a average temperature of 97.8. So I'm going to toggle back. How do we feel about those odds? I'm going to call on someone just for a sign of life because I'm silently talking in my dining room. Kai, how do you feel about a 0.008 probability? Do you mind unmuting yourself? Breaking the silence in my house?
Yes, but could you also elaborate on that a little bit?
I could. So basically, we looked at the chance of getting a value of 97.8. We looked at the chance of getting this value or less than this value. Or we didn't care which way because we did not equal to. So we could also look at the other option, which is a temperature of 99.4 or greater than that. So the chance of landing on either side here overall, like getting a sample with either, that falls in either one of those buckets, is 0.008. So how do you feel about a 0.008 chance?
that is a very small probability of that.
Yeah. Yeah, it shouldn't have happened. So basically what we're saying is like, okay, this is a very unlikely temperature if normal body temperature is 98.6. Like we should not have obtained a sample that has this low of a temperature. Like that's not going to happen. So that indicates to us that probably body temperature nowadays is less than 90, could be less than 98.6, or in general is just different than that value. So fun fact, COVID temperatures difference, all the things. So to make a conclusion, we do have the 3 sentences, and you can always follow this structure. So it says, assuming the null is true, we have an average temperature of 98.6. Assuming that was true, there was a 0.008 probability of obtaining our result. So we can say this a few different ways. You can list the numbers that we had, or you can say within 0.8 of this number. So there's a few ways to phrase that. You can say, the chance of us getting a temperature less than 97.8 or greater than 99.4, or you can just say within 0.8 degrees is another way to phrase it. So a result within, I'm going to say within 0.8 degrees, purely by chance. So you can say, or you can say the less than, greater than signs, whatever. So then, does this convince us? So we have to kind of remember this stuff over here. We haven't done a significance test in a while, but basically, if we get a weird probability, we go, doctors think it's 98.6, but shoot, our sample is 97.8. That's kind of weird. And then, that result really shouldn't have happened. Like there's no chance if normal body temperature is 98.6 that I should have gotten what I got. So we can say that provides strong evidence against my original claim, and is statistically significant, because I'm going to throw out my original claim. So for, if you're thinking something is true and you're tossing that out, that's significant. You're changing what you think. So that is statistically significant. So therefore, just like Anthony Wycamp shouted in the halls at Wellspring in front of the principal 3 years ago, we're going to reject the hoe. So we're going to reject the null hypothesis and conclude that normal body temperature is not 98.6. And again, I included kind of less than and greater than directions for that. So we can just say it is not what we thought it was, since we did a not equal to scenario for that. So I think we're going to call it a day on that right here. So before I switch to the important ideas, we're going to look at some calculator stuff on Monday. I don't know if my brain has the capacity left, probably like the rest of you. But before I toggle to the important ideas, what questions do we have about a one sample t-test? You're going to see yourselves for a second. I'm going to toggle back to the chat so I can see it. What questions do we have about a one sample t-test? So these were all the steps. There's a recording from yesterday too, if you haven't looked at it yet, that kind of goes through each of the parts a little bit slower. What questions? Drop them in the chat, or you can shout at me and break the silence in my home. Okay. Somebody typing? Nobody's typing. Okay. Let's go ahead then. This was a one sample t-test. We're going to look at, if you have the printed notes, we're going to look at some of this calculator business on Monday. We're just going to start with that because my brain also is tapped. Okay, here's what we did. So we've got 4 steps again. So if you need to remind yourself what has to be included there, this is a nifty little way to write that, kind of a little cheat sheet for yourself, that first half of the important ideas box. And then this part we haven't done yet. We're going to do this on Monday. We'll look at kind of the link between a confidence interval and a test, a two-sided test, so a not equal to situation. So you don't need to write this part just yet. We'll look at that Monday. But otherwise, this is just kind of the generic format if you need that written down. We didn't check the conditions today because we just assumed they were going to be met because we were going to struggle to meet them with a small group. So we just assumed they were good. So that is it for today. Feel free to write these down. I did record everything, including my calculator struggle, so that's good. So go ahead and feel free to bop off. Have a great weekend, and I will see you guys. See some of you on Monday. Actually, we'll see people again. So it's great.